Good morning everyone. I am Dr. Aparna, Associate Professor and Head of the Department of Mathematics and Management Sciences. Today I am going to explain the applications of Jacobian Determinant and related problems. Jacobian Determinant is used for calculating complex integrals like double and triple integrals. The Jacobian Determinant is a powerful concept in multivariable calculus that measures how a transformation changes area or volume. Major applications of Jacobian determinant is change of variables in multiple integrals, inverse function theorem, robotics and kinematics, stability analysis in differential equations, fluid mechanics and economics. In all the above areas, Jacobian determinants are very much useful. First of all, I am going to give the definition of Jacobian determinant. Jacobian. Let u is function of two variables x and y. V is also a function of two variables x and y. The determinant dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y is called the Jacobian determinant of u comma v with respect to x comma y. This determinant is denoted by j of u comma v with respect to x comma y, and also it is denoted by dou of u comma v with respect to dou of x comma y. Therefore, finally, Jacobian determinant is denoted by j of u comma v with respect to x comma y or dou of u comma v with respect to x and y. Here, u comma v are dependent variables, x and y are independent variables. Suppose if u is function of three variables x comma y comma z, v is also function of three variables x comma y comma z. Assume that w is also having three variables x, y, z. Then Jacobian determinant of u comma v comma w with respect to x comma y comma z can be calculated by using the determinant form dou u by dou x, dou u by dou y, dou v by dou x, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. Therefore, Jacobian of u comma v comma w with respect to x comma y comma z can be calculated by using this determinant. Now, I will explain how to calculate the Jacobian determinant for two variables. I will explain by using one example problem. If u is equal to x plus y by 1 minus xy, v is equal to tan inverse x plus tan inverse y. find Jacobian of u comma v with respect to x comma y. OR another notation is dou of u comma v with respect to x comma y. Here in this problem, x comma y are independent variables, u and v are dependent variables. For calculation of Jacobian determinant value, first of all we are going to calculate the partial derivatives of u and v with respect to x and y. Here given that u is equal to x plus y by 1 minus xy. From this we have dou u by dou x is equal to dou by dou x of u is here x plus y by 1 minus xy. This is of the form dou by dou x of u by v type. Dou by dou x of u by v is equal to v into dou u by dou x minus u into dou v by dou x by v square. This value will be equal to v. What is v here? 1 minus xy. 1 minus xy into dou by dou x of what is u here? Here u is x plus y minus u into here u is x plus y into dou by dou x of v is 1 minus xy divided by v square. V is here 1 minus xy whole square. Here this is of the form dou by dou x of u by v. This is u, numerator u, denominator is v. Substituting u and v in this formula, you will get this step. This value will be equal to 1 minus xy into dou by dou x of x plus y with respect to x is 1 minus x plus y into dou by dou x of 1 minus xy with respect to x is minus y divided by 1 minus xy whole square. So after simplifying, you will get the numerator value will be equal to 1 plus y square by 1 minus xy whole square. Therefore, finally dou u by dou x is 1 plus y square by 1 minus xy whole square. Finally, we will get dou u by dou x is 1 plus y square by 1 minus xy whole square. Now, we are going to calculate dou u by dou y. Dou u by dou y is differentiation of u with respect to y partially. That is dou by dou y of u here. In the given that u is equal to x plus y by 1 minus xy. This is also in the form of d by dx of u by v type. Apply the definition. When you are applying the definition, we have this is v into 1 minus xy into differentiation of numerator term with respect to y. Dou by dou y of x plus y v into derivation of u minus u into x plus y into derivation of v. Derivation of v is 1 minus xy with respect to y by v square 1 minus xy whole square. So that is 1 minus xy times of dou by dou y of x plus y is with 1. X plus y times of dou by dou y of 1 minus xy is minus x divided by 1 minus xy whole square. Simplifying the numerator term, we have dou u by dou y value will be equal to 1 plus x square by 1 minus xy whole square. Similarly, we are going to calculate the partial derivatives of v with respect to x and y. Here, given that v is equal to tan inverse x plus tan inverse y. Now, we are going to calculate the partial derivatives of v with respect to x and y. First order partial derivatives. dou v by dou x is equal to dou by dou x of tan inverse x plus tan inverse y. D by dx of tan inverse x is equal to 1 by 1 plus x square. Similarly, dou by dou x of tan inverse x is 1 by 1 plus x square. Differentiation of the second term with respect to x is 0 because tan inverse y is constant when you are differentiating partially with respect to x. Therefore, dou v by dou x is equal to 1 by 1 plus x square. Next, dou v by dou y is equal to dou by dou y of v is tan inverse x plus tan inverse y. Derivation of tan inverse x with respect to y partial derivative is 0 plus dou by dou y of tan inverse y is 1 by 1 plus y square. Therefore, finally, dou v by dou y is equal to 1 by 1 plus y square. Dou v by dou y is 1 by 1 plus y square. Therefore, Jacobian determinant of u comma v with respect to x comma y is equal to, according to the definition, this value can be evaluated by using the following determinant: dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. From the previous stage, already we calculate from the previous step, we calculated the value of dou u by dou x and dou u by dou y. Here dou u by dou x is 1 plus y square by 1 minus xy whole square, and dou u by dou y is 1 plus x square by 1 minus xy whole square. Put it, these all values in this determinant we have. Determinant of dou u by dou x is 1 plus y square divided by 1 minus xy whole square. Dou u by dou y is 1 plus x square divided by 1 minus xy whole square. Dou v by dou x is 1 by 1 plus x square. Dou v by dou y is 1 by 1 plus y square. So here this is of the form 2 by 2 determinant. This value is equal to 2 by 2 determinant can be evaluated in the form of AD minus BC. This is 1 plus y square divided by 1 minus xy whole square into 1 by 1 plus y square minus 1 plus x square divided by 1 minus xy whole square is multiplied with 1 by 1 plus x square. Simplifying, finally you will get the terms gets cancelled. This term and this term gets cancelled. Remaining expression is 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square. These two terms gets cancelled. Finally, we will get 0. Therefore, Jacobian of u comma v with respect to x comma y is 0. Now, I will explain the second problem. If u is equal to x square minus 2y, v is equal to x plus y plus z, w is equal to x minus 2y plus 3z. Find Jacobian of u comma v comma w with respect to x comma y comma z. So here in this problem, u is function of xyz, v is function of xyz, z is also, w is also function of x comma y comma z. Here, given that u is equal to x square minus 2y, then dou u by dou x is equal to differentiation of u with respect to x partially, dou by dou x What is u here? X square minus 2y. Dou by dou x of x square is 2x. Differentiation of 2y term with respect to x is 0. Next, dou u by dou y is equal to dou by dou y of u is x square minus 2y. Differentiation of x square with respect to y is 0. Differentiation of minus 2y with respect to y is minus 2. Next, dou u by dou z. Dou by dou z of u is x square minus 2y. Derivation of x square with respect to z 0. Derivation of minus 2y with respect to z is 0. Finally, you will get dou u by dou z is 0. Similarly, given that v is equal to x plus y plus z, then dou v by dou x is equal to dou by dou x of v is x plus y plus z. Derivation of x with respect to x, partial derivative, is 0. 1. This is 1. Partial derivative of v with respect to x is 1. Partial derivative of y with respect to x is 0. Partial derivative of z with respect to x is 0. Dou v by dou x is 1. Dou v by dou y. Derivation of v with respect to y is dou by dou y of v is x plus y plus z. That is, derivation of x with respect to y is 0. Derivation of y with respect to y is 1. Derivation of z with respect to y is 0. Partial derivatives. That is 1. Similarly, dou v by dou z is equal to 1. Now, coming to the third function. Given that w is equal to x minus 2y plus 3z, dou w by dou x is equal to dou by dou x of w is x minus 2y plus 3z. That is, derivation of x is 1, derivation of 2y is 0, 3z is 0 with respect to x. Next, dou w by dou y is equal to dou by dou y of x minus 2y plus 3z. This value will be equal to minus 2. Next, dou w by dou z is equal to dou by dou y of x minus 2y plus 3z. Derivation of this expression with respect to z is equal to 3. Now, Jacobian of u comma v comma w with respect to x comma y comma z is equal to, the definition is determinant of dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. This value will be equal to dou u by dou x value from the previous step is dou u by dou x is 2x, dou u by dou y is minus 2, dou u by dou z is 0. So put it here. Dou u by dou x value is 2x, dou u by dou y is minus 2, dou u by dou z is 0, dou v by dou x is 1, dou v by dou y 1, dou v by dou z is also 1. Next, dou w by dou x is from the previous step 1. Dou w by dou y is minus 2, dou w by dou z is 3. Expanding this determinant, we will get finally 10x plus 4. Therefore, finally, Jacobian of u comma v comma w with respect to x comma y comma z, value will be equal to 10x plus 4. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.